Okay, guys, this is for lesson 6.1. I've got everything already done here. So, because Miss Menard already kind of gave you guys one supplemental, so this is more of a quick one to kind of review all the different problems. And remember, the examples I got in here, they're all unique. So you got to use your example, don't use mine. Okay. All right. So here's the first one. You're given two functions, and it's asking you where they intersect. So remember when they ask you for where they intersect, it's basically asking you where they're equal or where they cross on a graph. So what you do is you take both functions. So here's my two, and I make them equal to each other. And since it's x squared in the function, I got to make sure I make it all equal to 0. Once I make it equal to 0, then I've got to factor this out with x and with the box. And you can look through all those steps there. And this is what I get, 2x plus 3, x minus 2. And then zero product property says if that's negative 2, that's positive 2. And that's negative 3 over 2. Okay, so but remember, I'm looking for where they intersect, so I'm looking for the y value as well, like the actual point where they cross. So to find that y value, I plug in the x value into the easier equation. Okay, so I plugged in 3 over 2 to 2x plus 3, and what happens is the 2's cancel for that 3 over 2, and I get 3 plus 3 is 6. So then there's my point where the graphs cross at negative 3, 2, and 6. And then for the other point, I plug in the 2, this value, and I get 2 times 2 plus 3, 4 plus 3, 7, and then I get that value there. So if I show this to you on a graph, I get 2x squared plus x minus 3, and then the other graph was 2x plus 3. You can see that that's one of the solutions, 2, 7. And then the other solution right here is at I realized I made a mistake, and I see what my mistake is. That's actually supposed to be negative 150. And I see what I did, that when I plugged in the 3 halves here, I forgot the negative. So I should have made that negative, which makes that negative, and negative 3 plus 3 ends up being 0. So I get 0 here. Okay, so but that's one way you can check your work, just in case you make a mistake. Okay, so now here's two functions. I got y equals 1 over 5 and y equals 5 over x plus 9. Since they're both equal to y, I make them both equal to each other. So 1 over 5 equals the 5 over x squared plus 9. And then it's like a rational equation, so I cross multiply. So 5 times 5, 25. And then 1 times x squared plus 9. Well, that's just x squared plus 9. And then I will get the x squared by itself. So I subtract 9 from both sides. I get x squared equals 16. I square root it. And then remember, you get two solutions, positive and negative 4 there. All right, this one, it gives you an equation. And it's asking you, okay, what if you multiplied 10? Or what if this girl, Jenna, multiplies 10? What is she going to get on her second step? Well, you would multiply 10 here. I decided to make my own equation, and I'm multiplying 6. So if I multiply 6 on the first one, then I would cross out the fraction that has 6, and I just end up with 4. But the ones that don't cross out, because they don't have 6, they don't cancel. So then I multiply the 6 times the 10. That's what I'm doing here. 6 times x, that's what I get here. Okay, but then, so that's her new equation, right? Of course, you got to do it with your own. Now, what should she multiply to eliminate the remaining fractions? Well, in order to eliminate the x plus 1, I multiply x plus 1 to every term, or every fraction and every number. So I multiply it there, those cancel, so I get 60. If I multiply it times 4, I got to just basically do 4 times x plus 1. And then here, the x plus 1 cancels, so I get 6x. And now I just basically distribute there. I add these two like terms together. I take away the 4x from both sides. And the rest is history. Okay, you can kind of see how that's done. All right, so the next one's down here. All right, these are the square root problems. You guys seen a lot of these. Okay, so here's mine. So remember, the first step is always you got to square both sides. And don't forget that if it's 2 numbers here, you got to expand it out and double it, basically. So you'll double that x minus 2. And then you need to multiply it either foiling or using the box. Here you can see I used the box to multiply it out. And then I wrote those terms right here. And remember that 4x comes from these two like terms. Okay, and since it's an x squared again, just like that first problem, I need to make it equal to 0. Okay, make it equal to 0 by taking away the 10, adding the x, and then I end up with this, x squared plus 5x minus 6. Again, I got to now use the x and the box to factor, basically doing the reverse box. Okay, so remember with this one, a times c, so it's negative 6 on top, 5 on the bottom. Don't just automatically think it's 2 and 3, because 2 and 3, you can't, there's no way you can combine them to get a negative 6 and a positive 5. Okay, you could get a positive 6 and a positive 5, or a negative 6 and a negative 5, but you can't get ones with different signs. So I had to use 6 and 1. So I plugged that in there. Then I found the factors on the outside. Now here I have x plus 6 and x minus 1. And then once I get my solutions, the negative 6 and the positive 1, I need to plug them in to check them. And so that's the big step with this one, is making sure you check for extraneous solutions. So here, when I plugged in negative 6, I got positive 16 here, 16 square root of 16. Here I got negative 6 plus 2, that's negative 4. And I can't have a negative, and the square root of 16 is positive 4, not negative 4. So when you're checking the solutions, you only account for the positive. It's not like positive and negative like the other ones. Okay. So, but when I plug in the 1, it did work, and I get a good solution. So my only answer is x equals 1. Okay, so now for this one, absolute value, you got to remember with these, you need to split it into two different equations. So the first one, you just keep it just like it is. So it's x plus 2 and negative 3x plus 6. But the second one, I need to switch the signs. So I got to switch these signs, and that's negative 3x and minus 6. Okay, and then I just solve each side of those equations. You can kind of pause and see how I work through those. Okay, on the back side, here, what I did is I had to get the equations equal to y first. So here I subtracted the 3 from both sides, and here I subtracted the 3x from both sides. That way I have one equal, this equation equal to y, and, this equation also equal to y. And then I just set them equal to each other. And now you're basically just looking at the same problem as the first one in this homework assignment, and doing it the exact same way. You're just going to set them equal to each other. You're going to end up doing the x in box. And then to figure out where they intersect, you'll have to plug those numbers back in. Okay. And I think for this one, yeah, so you'll have to plug them back in to solve for y. All right. So this one, similar actually, except the other one's not a linear. It's not a y equals mx plus b. But you still do the same thing. We're still going to set them equal to each other and then get it equal to 0, just like the last one. But now you're just factoring this equation here. So you can kind of see how I took away all these terms to get it equal 0. And then I set up my x here. And I kind of found those numbers for you because I know it's a bigger number. So to kind of help you out, I put the negative 14 and negative 6. Those are the two numbers that add up to negative 20 and multiply to 84. But you got to plug in the box, figure out the factors on the outside, put those here, and then figure out the solutions. Now, what you could do to find y, an easy way to do that is to take your x and plug it into the equation using Desmos. Because some of these are going to be fractions, and it might be a little hairy to plug that into a fraction, or it just honestly might save you some time to plug it in. So for instance, let's say like my solution's like 3 over 2. Well, and I know this isn't the same. Actually, let me pull one of those functions. So like, let's say it's 2x squared minus 8x plus 7, and you have to figure out what the y is. All I'm going to do is plug in 3 over 2 here, and don't forget the little squared there. So hit the square, and then minus 8, but remember you have to plug it in twice here. And then, what was it, plus 7? Then plus 7. So let's just say that was the solution, right? Then my y, after I plug that in, is negative 0.5, which is the same as 1/2, okay? And actually, it might be better for me to use the other Desmos calculator in this case, just because it's going to actually help me give me the fraction, just in case I have a fraction that I'm not familiar with. I mean, I know that one's 1/2, But let's say I just basically copy and paste it, by the way. And so I get that, right? So if I hit that, it'll tell me what the fraction is. So that might be more helpful to you guys to use that one. Okay. You could skip this one. This one, square root function. Again, this one's easy because you're squaring both sides and they both radicals disappear. So it's a pretty simple equation to solve. Again, remember, follow yours. Don't look at mine. Don't copy mine. This is just like the absolute value problem on the first part of the page. I said the only difference here is that now I've got these other kind of coefficients on the outside, which I need to get rid of. I need to get, you always want to isolate like that main part of the equation, whether it's isolating a radical, I isolate the absolute value. In this case, I'm adding the 5 to get rid of that to both sides, and then I divide the 4 on both sides, and now I have the absolute value by itself, and now I can split it. So remember, you write it normal for the first one, right, without the bars, and the second one you change all the signs on the right. Okay, so if it's only one number on the right, then you just change that to -7, solve both sides, and then you get your solution there. You can kind of take a look at my work there just to help you figure that one out. Okay, so this last one. Okay, another square root problem. Still same approach. I'm going to square both sides. End up with 9 here. End up with this squared term and this x term and a constant. So that means square term, make equal to 0. So I subtracted 9 from both sides and I get this. And then I brought this up here and did my x in box. You can see I set that up. I plugged all those numbers in the box. I figured out the factors on the outside. Then I plug them here in the parentheses. Then I use zero product property to find that -3, the solution is +3. And then from 2x plus 3, it's -3/2. And I made sure and I checked. So I plugged them in. Now the nice thing about ones where it's like it has a little squared inside, it's most likely they're both gonna work. But you still want to be sure to check. But I'm saying most likely. There could be a case where it doesn't work. So you can see I plugged in the 3 there. And remember, you got to plug it in twice. You got to plug it into that x and that x. So you see I plugged it in here to the 3 there, and then I simplified and see that those are equal. Now this one is a fraction that I'm plugging in the second one. So you can see I kind of worked it out by hand. You don't have to do that way. You could literally like take what I did here and plug that also into Desmos. So I could do it like this. I want to start with the radical first, and I'll do 2 times, I think it was -3/2, and then I got to make sure I put the little squared on the outside, and then minus, I think it was 3x, or 3 times my solution, so 3/2 there. So this could be one way you guys could do it. That way you can check your answers real quick, and you can see it equals 3, and that's what I was looking for, just like you can see down here. So again, use Desmos to check your answers. Okay, that's it.